In this lesson, we're going to examine quadratics and their inverses, much in the same way we did linear functions and inverses in the first unit. So we'll look at some of their properties, some of their equations, and their pictures, of course. We're going to approach them the same way, the idea that we can swap things. And the only challenge with quadratics is when you create an inverse of a quadratic, the resulting relation is not always a function. In most cases, it's actually not a function. So let's take a look at some. To graph an inverse, we're going to swap our coordinates again. Don't change signs, don't change numbers, just change position. So in a function like the red one here, 0, 0 will become 0, 0. 1, 1 will become 1, 1. And negative 1, 1 will become 1, negative 1. Okay, so we're just swapping coordinates. But if you notice, this inverse is not a function. Our vertical line test doesn't work, not a function. So we need to figure out how we can create a function out of this. And the way we're going to do that is we're going to place a restriction on our original function. A restriction means we want to only have part of the original. So if we go back to the picture for a second, if we were to take this initial quadratic, but only part of it, let's say we took just this half. Well, when I draw the inverse, I would only have half of the new function. Well, if I only have half, it passes my vertical line test, and I have a function again. Okay, so we call this a restriction, creating part of a graph. The way it's going to look is like this first example here. So I've got a parabola. We know that's the function. And then I have this little piece right here. And we call this a restriction. It's going to create only part of our graph. In fact, it only wants the part less than negative 2 in terms of the x's. What does that mean? Well, let's sketch it. If we look at the function, the parabola, it has a vertex of negative 2 and 3, and a step pattern of negative 1 times 1, 3, 5. In other words, negative 1, negative 3, negative 5. So when I start my vertex of negative 2 and 3, which is right here, I need to go over and then down 1. Now remember, we have this restriction of less than negative 2. So I can only go to the left of negative 2. So over 1, over 1, down 3, and over 1, down 5, and I create this function. I don't go to the right because in my restriction it says x's have to be less than negative 2. In other words, from here to the left. So when I go to do the inverse, we can use our idea of swapping coordinates. What are the coordinates we have for the green one? We have negative 2 and 3, our vertex. We have negative 3 and 2, that's the first point down. And then we have negative 4 and negative 1. Let's swap those. So 3, negative 2, right there. 2, negative 3, right there. Negative 1, negative 4, right there. And we'll connect them. And it looks like this. And that thing is a function. So you can see how our restriction helped create part of a parabola and resulting in part of a inverse. We're asked for the domain range. So let's do that. Our domain for our original is actually the restriction, right? Less than negative 2. Our range, y, has to be less than, it reaches a height of 3, the vertex. For our inverse, our domain, left and right, what do we got there? X is less than negative 3, and our range, y, is less than negative 2. And you might recall domain and range are swappable, just like points. Swap, domain and range, swap. So that became that, and that became that. Okay. Let's look at the equations. How do we find the equations of these things? So if you recall, we swap the x and the y, and then we undo BEDMAS. We call that SAMDEB. And worked our way backwards when we did linear functions. Same is true with quadratics. So let's swap our x and our y and undo. So we need to start with any subtracting and adding. I bring the 3 over first. I then need to undo any multiplying or dividing, and I've got that. I've got that negative 1 out front, so I need to divide by the negative 1. And then I have to undo any exponents. I have one of those. To undo an exponent of a squared, I need to go to the opposite side and square root. Now here's one little trick. You need a plus and a minus in front. Okay, we don't know if we have the positive radical or the negative radical, so we have to put down both. We're left with y plus 2. And then we have to undo the brackets part, so that 2 comes over. It's going to go out front, and we're left with this equation. Okay, now there's different ways of writing this. Our inverse, of course. We can write it the way it is, or when you divide by negative 1, it's the same thing as multiplying by negative 1, right? So sometimes you see this. That looks like function notation, if you will. Or if you wanted to, you could leave it in the fraction form, like this. That would have been fine there too, okay? But either way, there's our inverse function. Okay? It's gone from being a quadratic to being a radical. And right now, this actually wouldn't be a radical because of the fact we have this plus and minus. So we'd end up with a positive version and its reflected version, vertical reflection, so not a function. Okay, you guys are going to try some stuff. So pause it, give it a try. So we're going to sketch, we're going to figure out equations, we're going to do all that good stuff. So let's sketch the function first. What do I need? My vertex, my step, 0.5 times 1, 3, 5 is 0.5, 1.5, 2.5, negative 1 and 2. I need to go over 1, up a half, over 1, up 1.5, over 1, up 2.5, 1, 2, 2.5, about here. Now, I didn't talk about it, but you did notice, I hope, that there was a restriction here, right? That's why I went to the right only. I did not go to the left. There's my function. That's f(x). And I want to do its inverse. So inverse, my point is 2, negative 1. So 2, negative 1. And I can make my list if I wanted to of points again. There's nothing wrong with doing that. So blue points would be like 0 and 2.5, and then 1 and 4. You can do that, or we can do our step pattern idea. Hey, if you turn your head sort of to the side, instead of going over and then up, okay, we reverse those things. We swap the components. So I'm going to go to the right one, which actually means down 1, and then up 0.5. Down 1, and then up 1.5. Down 1, and then up 2.5. And I'll get my inverse function. Oops, you know what? I messed that up. Went the wrong way. Over 1, sorry, our vertex is 1, 4, 4, 1. No, vertex is 2, 1, negative 1. There. I went the wrong direction. I should go to the left, sorry. 2.5 and 0, 1, 2, 2.5 and 0. And then a left 1 and up 1.5, and left 1 up 2.5. I went the wrong way and my head was turned sideways. Okay, there's your inverse. We're asked for the domain and range. We can think about our original domain, which we were given in the question. X had to be greater than negative 1. Our range, y had to be greater than 2. So real quick, we do the swapping idea. We know our domain, x would be greater than 2, and our range, y is greater than negative 1. Okay, which matches our picture. And then we want to find our equation. So let's take some space here. Okay, so our equation. First thing we need to do is we need to swap the x and the y. So y equals, or x equals now. X equals 1/2 bracket y plus 1 squared, and then plus 2. Okay, so undo bedmass, SAMDEP, subtract it first. And you divide everything by a half next. When I divide by half, x minus 2 over a half, We talked about that being the same thing as multiplying, right? So in other words, like this. Okay, this became that. Okay, undo my exponent. So the square root of 2 bracket x minus 2. Get the plus and minus in front. And then I bring that 1 over. And it becomes negative 1 plus minus root 2x minus 2. There's our inverse. Our inverse function is negative 1 plus minus root 2 bracket x minus 2. We're going to ask for something else. What else were we asked for? Find f inverse at 10. So let's do that. Function notation. Now, how many answers are there going to be this time? 2, because I have that plus and minus involved there. Okay. But we have to actually ask ourselves, which one do I want? What's the restriction? So I skipped over it, but back up here, by restricting the domain of the original, we're in effect restricting the range of the inverse. So it wants us to find f at 10. I'm only allowed to have y values that are greater than or equal to negative 1. So even though I'm going to get 2 answers here, I got to pick the appropriate one, the admissible one. So let's try that. What are we going to get? Negative 1 plus or minus, plus or minus the square root of 2 times 8, negative 1 plus or minus the square root of 16, negative 1 plus or minus 4. So if we add them, negative 1 plus 4 will get 3, or negative 1 minus 4, we get negative 5. Now remember, what was our restriction? The y values, the function values, had to be greater than negative 1. So I can't have this one. That's inadmissible. So my inverse at 10 has to be 3. Okay, it's the only one that we're allowed to have based on that restriction. Okay, last one. Here's a picture. Can you figure out what the function is? Can you graph the inverse? Can you do some restrictions? Can you figure out the equation? So let's take a look at our function. What do we notice? We notice there's a vertex, hopefully, of 1, 2, 3, 4, 5, 2, and 5. So x minus 2 plus 5. What's the step pattern? So if I start the vertex and I go over 1 and down, 2, over 1 and down, 6, it looks like. 1, 2, 3, 4, 5, 6 right there, yep. Yeah, it seems like a constant pattern of 2. And if you couldn't figure that out, you could also have solved for A. Let's graph our inverse. Let's swap our points. So 2, 5 becomes 5, 2. And this one's going down. So in ours, we're going to go to the left. So up and then over 2, down 2. Up and then down 6. 1, 2, 3, 4, 5, 6. Down then 6. Okay. I get that shape. Okay. State restrictions that make the inverse a function. Well, we know right now the inverse is not a function, but if I were to cut the original function in half, then I would get half, right? So what's a restriction I could place on that first thing? If I said x had to be greater than or equal to 2, or x had to be less than or equal to 2, I would produce half. Greater than 2, I'd get this. Less than 2, I'd get this, which means I'd get either this one or I'd get this one. Okay, so if you cut in half at the vertex, we're going to produce half a parabola, which produces half of an inverse. All right, last try. Let's find the equation of that inverse. Just one more time with this. That's usually the tricky part. So x is y is x. So x equals 2 bracket y minus 2 squared plus 5. What do we get? We get x minus 5 equals 2 y minus 2 squared. X minus 5 over 2 equals y minus 2 squared. I don't like to divide by 2, so what did we say we would turn into a fraction? That means the same thing, right? So the square root of 1/2 x minus 5 equals y minus 2 Don't forget the plus and minus out front. And then the last line, hopefully you're pretty good at this by now, 1/2 x minus 5. So if you're writing function notation, our inverse is 2 plus or minus 1/2 x minus 5. And there's your function. So our big ideas today, can you find the equation? Can you find graphs? Can you look at properties, domain and range? In case you hadn't figured it out by now, x squared and root x are the inverses. And we've talked about that all the way through. Just one more last point. Okay, homework to try. If you're stuck on something, come see me, and we'll move on to some new concepts tomorrow.